Okay, let's do one more section. So the next section we're going to talk about is the addition of water, hydration of alkene. Just be aware, this is the opposite of dehydration of alcohols, which is we just talked about going through the E1 mechanism. And how do we then know what product we're going to form? Remember when we did the lab for the dehydration of cyclohexanol to form cyclohexene? One of the things we did was we actually did a fractional distillation and we removed actually water plus our product. So by removing this, we use Le Chatelier's and we drive our reaction to the right. So how do we drive our reaction to the left? Okay, well we know water is a product for this way. Then if I add excess water, my major solvent, if I have excess amount, then we would actually drive addition to the alkenes to make the alcohol. So this is where we use Le Chatelier's principle in order to determine which way we go in terms of the types of products we want to form. Okay, so microscopic reversibility, yet by using Le Chatelier's we can determine whether we're going to make the alkene or, in this case, if we want to start making the alcohols. So let's go through the mechanism then for addition of water. Okay, so when we do the electrophilic addition of water, the one thing that I want you to notice is that we always add a little bit of acid. Okay, so if we take a look at the mechanism here. Okay. Take a look at the mechanism. We have our alkene. We have water. And we're going to add a catalyst, acid, typically in the form, in this case, of dilute sulfuric acid. So the first thing that happens is my alkene, my pi bond, attacks my electrophile. When it does that, okay, so going back to the mechanism behind how we can add water to an alkene, we do need an acid as a catalyst, okay? And since we're adding acid as a catalyst, the bottom line is that my alkene adds onto my electrophile, and so you form a carbocation. Once I do that, with the presence of water, now my water can act like a nucleophile and attack my carbocation. When I do that, for my next step, I get a protonated alcohol. And my solvent, again, which is water, pick up my acid, I regenerate my catalyst, and I get an alcohol in the process. So that's how you get hydration of an alkene. Okay, and notice this is going to add in the Markovnikov orientation. Okay, and this all leads to, goes back to your mechanism on looking at the stability of your carbocation. All right, so let's take a break and get some examples.